Welcome to another exercise for the workbook Statistics. This time I'm going to talk about the topic of Markov chains. So our exercise here, students are rated regarding their marks in the four categories A, B, C and D. A student from the top category A has a probability of 18.7% to move in the next semester into category B, 3.3% to move to category C, and 0.9% to move to category D. Then, a B-rated student has a probability of 14.6% to switch to A, 7.6% to switch to C, and 4.5% to switch to D. A C student switches with 8.1% to A, 12.2% to B, and 15.3% to D. Finally, a D student is rated with a 0.4 probability to switch to A, 4.7% to switch to B, and 11.8% to switch to C. Maybe I got those numbers if I observed development of students over longer periods of time. However, I can summarize this and then ask the question, determine the long-term shares of the four categories that will result at the university. So how many, relatively speaking, students are situated in category A, B, C and D? How do I go about solving this problem? Well, first off, I use the information given in the relatively long text to build my Markov transition matrix. And that's basically all the information we had. The probabilities to switch from A to B, from A to C, from A to D. And whatever is not covered in any of these three categories means they remain in category A. Same for B. That's for switching from B to A. That's for remaining in B. That's for switching to C, switching to D. And so forth for the other ones as well. So we see there's a pretty large chance of remaining in one's same category. Once we have this transition matrix, what we're going to do is first off, we calculate the transpose of this matrix, which simply looks like this. And then we build a system of equations. So more or less, we are calculating the kernel of this transposed matrix, which however is slightly different from the original one. Because if we look closely, here on the diagonal, we have these elements, and those are all negative. We get these numbers, or we get this matrix, if we subtract from the original transposed matrix the unit matrix. So on the diagonal we have the original values minus 1. And of this matrix we're going to calculate the kernel, or rather all those solutions where the end result will be 0. So that's nothing else than solving a linear system of equations. However, we're going to find one particular solution, because in this case we will get an infinite number of solutions. We want to have this one particular solution where all the results will add up to 1, speaking to 100%. If we do this, if we simply solve this linear system of equations, we could use Gauss algorithm or any other algorithm to solve linear systems of equations. We will find exactly one solution which fulfills this additional condition. That's the solution here of 0.2629 for A, 0.3086 for B, 0.1765 for C, and finally 0.2541 for D. Those are the shares for each of the three categories. So we see the largest category will be B, then we will get A, then D, and finally C. If we were to add up all these numbers, we would get 100% or 1. Well, that's everything there is to working with Markov chains. So the hardest part is actually coming up with this transition matrix. Then we simply have to transpose this, reformulate this slightly, and solve a system of equations. Well, that's it. So I hope you enjoyed this short session. I say goodbye and see you next time.